There are three types of linked lists: single linked list, double linked list, and circular linked list. In this video, we will majorly discuss the single linked list, but I will mention double and circular, so you'll know what they are by the end. Also, I will be using Java for the explanation, but we won't be going hands-on with the code, so you can apply these concepts in any programming language of your choice. With the disclaimers out of the way, let's start. Linked lists. To the non-programmers who don't want to learn coding, you can learn Indian classical dance mudras.
Pataka means flag. Tripataka, three parts of a flag.
Linked list, just like array, is a data structure that stores information in a linear fashion. This means that every object is stored sequentially, and that when you traverse a linked list, you can only go to the next object after passing the previous object. However, unlike an array, the elements in a linked list are not stored together in the memory. They are scattered throughout. So if this is an array, each element stores some information, and in the memory, each element is stored one after the other. So it is easy for the program to move from one element to the next. Hence, it is easy to perform operations like traversing the elements, adding an element, or removing an element. But since this is not the case with linked lists, in order for us to perform these basic tasks, there needs to be something to hold the address of the next element. So each element in a linked list is not just one memory location. Each element has two variables called data and next. They store the data and the address of the next element respectively. This is done using pointers. Pointers are variables that can hold addresses of the memory locations. Think of it like this: inside the memory, each spot that can hold data has an address. For arrays, we don't need to use these memory addresses because we can just move to the right or left of wherever we are, and we will find the elements of the array. In a linked list, we as the programmers hold the address of the first element inside a variable called head. Head is pointing to the first element. When we display the data on the head, we first go to the position at which head is pointing, then we display the value in the data variable. The next variable is holding the address of the next element of the linked list. So in order for us to display the value of the next variable, we simply move to the position where next is pointing at, and then we display the value in the data variable of this element. Following these steps again and again, we can traverse the entire linked list. When we reach the last element, the next variable holds a null value. This is how the program knows that there are no more elements to display. A double linked list is slightly different because in it, along with the data and the next address, each element also stores the previous address. So traversing becomes possible in both directions. A circular linked list is similar to a single linked list, but the next value of the last element contains the address of the first element. So this creates a circle. Now let us look at the Java code for the single linked lists. Today is 18th May 2024, and this is the day 2 of the 30-day 15 uploads challenge. I had a very different video planned for today, but those calculations are taking some time, so be sure to subscribe to catch that one. Now to the code. In the code, we have a driver class called main and two classes called node and linked list. Each element in a linked list is called a node. Each node contains two variables. One is an integer type called data, and the other is a node type called next. In the linked list class, we have one variable called head, which holds the head of the linked list, and we have three methods. Insert at front method takes in integer data. Then we create a new node, and in the data variable of the new node, we copy the data. In the next variable, we copy the address of the head, and then simply replace the head with the new node. This way we have inserted a new data at the front of the linked list. The second method is the remove first node method. Here we first check if there is a head. No head means that the linked list is empty. So we can't remove anything and just return null. If the head is not null, we change the head to the next value of the head and then return what was previously stored in the data. The third method is called print list. For printing the linked list, we take a variable of node type called node and store head in it. Then we keep printing the data and changing the value of node to the next value of node till the node becomes null. This way we have printed the entire linked list. Here is the output of this driver code. Hopefully it makes complete sense. Now you know how linked lists work. Congratulations.
Trishula, trident of Lord Shiva, or weapon.